Do particles have a consciousness? The mystery of quantum observations. Quantum physics has brought us some of the most puzzling and profound questions about reality. But one of the most intriguing mysteries lies in the role of observation. Why does the mere act of observing a particle seem to change its behavior? This question has led to speculation about whether particles themselves possess a form of consciousness or whether the observer plays a deeper role in shaping reality. The quantum observation mystery, at the heart of this enigma, is the double-slit experiment, a cornerstone of quantum mechanics. When particles such as electrons are fired through two slits onto a screen, they create an interference pattern, behaving like waves. However, when the experiment is observed or measured, the particles behave like solid objects, forming two distinct lines instead of a wave-like pattern. This phenomenon, known as the observer effect, suggests that particles decide how to behave based on whether they are being observed. This strange behavior has raised profound questions. Is the act of observation merely a physical interaction, or does the observer's consciousness play a role? Do particles have awareness? Some interpretations of quantum mechanics propose that particles exhibit a form of proto-consciousness and inherent awareness that determines their behavior. While this idea is far from mainstream science, it stems from the difficulty in explaining why observation collapses a particle's wave function, turning it from a probabilistic wave into a definite state. The idea of particles having consciousness often ventures into the realm of panpsychism, a philosophical theory suggesting that all matter, even at the smallest scales, has some form of awareness. While intriguing, most physicists argue that this explanation is unnecessary and that quantum behavior can be understood without invoking consciousness, the role of the observer. Instead of attributing awareness to particles, many physicists focus on the role of the observer. In quantum mechanics, observation doesn't necessarily mean a human or conscious observer. It could be any interaction that forces the particle to choose a state, such as a measuring device. This interaction ties the quantum system to the classical world, collapsing the wave function and determining the particle's position or state. However, some interpretations, like the Wheeler's participatory universe, suggest that consciousness might still play a role, arguing that the universe requires observers to bring its potential states into reality. Scientific skepticism and open questions. Most scientists remain cautious about linking quantum phenomena to consciousness, emphasizing the need for measurable evidence. The Copenhagen interpretation, one of the most widely accepted frameworks, treats wave function collapse as a result of measurement without requiring consciousness.